Welcome back. As you know, I am Eli, the computer guy, and in today's class, we are going to be talking about routers. So these are an integral component to everybody's TCP/IP network, and they are an integral component to the internet itself. If we did not have routers, then the internet would not be able to exist. So what routers do is they route IP traffic based off of the IP address rules that have been created. So we've talked about routers in the past, and basically the thing that we've talked about with routers is routers are what separate your local area networks from the wide area network, so the LANs from the WANs or the LANs from the internet. Why it's important with a router is a router you can configure with rules for TCP/IP version 4, so IP address schemes, subnet masks, that type of thing, and then you can go in and you can manually create your network based off of whatever configuration settings that you want to build your network off of. Again, we've talked about switches. Switches are layer 2 network devices. Basically, they do not understand what IP addresses are. All they understand are MAC addresses, media access control addresses. Those addresses, more or less, are hard coded into the devices, into the equipment before it's shipped out of the factory. So the problem at the switch level is that you can connect all kinds of devices and computers together, but you can't really manually configure how they're supposed to communicate. So there we go. That's why we go up to layer 3 in the OSI model, the network layer. And at the network layer, that's where we're able to create things like IP addresses and subnet masks and all of those types of things so that we can sit down and we can manually configure an IP address scheme to state what should be the LAN, what should be the internet, what different networks should be, that type of deal. And routers are what separate LANs from each other, and they're also what routes the IP traffic throughout the internet. So we're going to be doing a basic class today on routers. This is one of those things, again, to be clear, to be crystal clear, you could spend hundreds and hundreds and hundreds of hours learning about routers. Routers have a hell of a lot of very complicated configurations. All the different vendors out there have their own ways of implementing different things within routers. And so today we're going to do like a 30 to 60 minute class on routers to basically explain what these routers are. And if you're interested in it, you can do a lot more education with Cisco or Juniper or whoever else if you want to go down that route. So today's class is just to give you a real overview of what we're talking about with routers so that you can be more confident when you go into your environment. So let's take a moment to diagram out where routers fit in your network environment and in the cloud in general, right? So you have your normal little switch, right? And your switch has your host computers connected to it. It has your servers connected to it. It has your printers connected to it, wireless access points, and the whole 9 yards. So basically any device connected to the switch, more or less, should be able to communicate with any other device that's connected to the switch. But the question then becomes, how can we have computers on this particular network communicating with computers on somebody else's network? Maybe go to something like a website, or maybe go from a remote site back to a headquarters facility, that type of thing. That is where the switch is going to connect to a router. So you're going to have a router, and what the router does is it routes IP traffic, so that TCP/IP version 4 traffic. It routes the traffic from the local area network into either the wide area network or onto the internet so that that traffic can get to wherever it needs to go, right? So we have what is called the cloud, the internet cloud, and basically the internet cloud is just made up of millions and millions and millions and millions and millions of routers. And all of these millions of routers are physically located in different places geographically. They are connected with different types of media media, maybe fiber optic cables, again, maybe some kind of microwave transmission, that type of thing. But basically what happens is if you have your computer on your local area network and it wants to communicate with a computer on an entirely different local area network, the first thing that'll happen is a computer will look on its local area network to see if it can find the computer. If it doesn't, it will then go up to the router. Router will say, oh, the IP address you're looking for is not on the local area network, so it will then forward that traffic up to the internet. From there, the routers on the internet will figure out the best path required to get to the router for the other local area network that you're trying to communicate with. This will come down into their router, which will then go into their switch, and then you'll be able to communicate, basically going through all of these different routers on the internet. Now, one of the important things to understand is when we talk about the internet cloud, there's a reason we talk about it as a cloud. And that reason is that most of the time, we honestly do not know how traffic is going to move through the internet cloud at any point in time, right? There are millions and millions and millions and millions of routers that make up the internet. And basically, when you try to connect to a different network from your network, depending on the current networking environment, depending on what's going on with certain routers and that type of thing, when you connect to the internet, your traffic is going to be routed through the most appropriate routers at this particular time. If you try to communicate 3 seconds from now, your traffic may actually get routed through an entirely different path to try to get to whatever resource you're trying to get through on the internet. So when we talk about the cloud, the reason we call it the cloud is it's just that thing over there. We go through the cloud. We deal with this. We deal with our routers. We deal with our switches. We deal with our servers. We deal with their routers, their switches, and their servers. But the cloud is just the cloud. Again, when you actually go through like an MCSE class or a Cisco class or something like that, generally how this is explained when they're talking to you is, right, you have your router here. This is connected to your switch. You have your server. And so in your class, you will be told how to configure your web server. In your class, you'll be told how to configure your switch. In your class, you'll be told to configure how to configure your router and your firewall and all of that kind of stuff. If you're connecting with something like a data center, right, basically you'll be taught how to configure the routers for the data center, the switch, the devices, all of that type of thing. But the important thing to understand is you will be taught to configure this side of your network, and you'll be able to configure this side of the network. But then the cloud is just the cloud. We're not really worried if there's Cisco equipment in the cloud or Juniper equipment on the cloud or Huawei equipment in the cloud. You just hit the cloud and then your traffic gets routed however it gets routed, and then it gets you to where you're going. And so this is just kind of one of those things to be thinking about when we start talking about routers. Routers are what route your IP traffic essentially from point A to point B. You may have a wide area network. So we've talked about before, we have WANs, we have MANs, and we have CANs, right? So a WAN is a wide area network, a MAN is a metropolitan area network, or a CAN is a campus area network. So with routers, right, you may have a number of different buildings in your campus environment, right? So let's say we have a number of different buildings, and these different buildings house different things, right? So this building houses IT, and this has legal, and this has HR, and this has the CXO, the executives, and I don't know, this other one has research or whatever else, right? So in these buildings are all going to have their own separate LAN. So inside the buildings are going to be their own separate LANs, possibly with their own servers, obviously with their own host computers, and the whole nine yards. But since all of this is part of your organization, you do want to be able to route traffic between these different buildings so that you don't necessarily have to go onto the internet in order for these different buildings or the people in these different buildings to communicate with each other, right? So basically, you would have routers in each one of these buildings that may connect to a fiber optic line, may connect to some kind of Cat6 line or something like that. And essentially here, you can create multiple connections from one router to another router. And the idea here is, so let's say the IT building is on the entirely other side of the campus from where the research building is, right? So if somebody in the research building wants to communicate with somebody in the IT building or a computer in the IT building, currently it may just simply route through HR, right? So you go from the router in the research building to the router in the HR building. The router for the HR building looks to see what the best path is and then just forwards that traffic on to the IT, right? So basically, this is your current path. But what happens if there's a power outage in your HR building? So for whatever reason, a transformer blows out and all the power goes out in the HR building. What the routers can do, since there are multiple paths, right? The router that's in the research building can look and see if there's another path to the IT building. So it can go, okay, let's see, I can do a connection down here to the legal building and then go up to the IT building. And so now I can automatically route that way. And so that's what the routers do, whether they are up in the internet or whether they're in your WAN, MAN, or CAN. Basically what the routers do is they route this network traffic based off of whatever the current conditions are. Now, before we get into talking about routing protocols, we need to take a second to talk about the physical routers themselves. So one of the things I've really hammered on in this networking series is the difference between logical devices and physical devices, and how, if you are a noob, you will rip out all of your hair because you will get very confused very quickly, because you will listen to the things that I say and then you will look at an actual physical product and then it doesn't seem to make a darn bit of sense, right? I keep saying switches are at the layer 2 level. They only understand MAC addresses. Routers, they understand IP addresses. And then you go and you pick up a networking device, and it's your router, and it's your switch, and it's your wireless access point, and it's a whole bunch of different other things. And you sit there and you're like, but what is this thing? But what is it? What is it? The important thing to understand is that basically what vendors do is they go and they find all of these different logical devices, and many times they assemble them into one physical device. So back when I got in the IT world, got my MCSE back with NT 4.0, the reality is most of the time all the networking devices were literally separate components. You purchased a modem, and you purchased a router, and you purchased a switch, and we didn't even have Wi-Fi back then, so you didn't worry about wireless access points, right? But these were all separate physical devices, so these classes were a lot simpler because I could point and say, that is the modem, and that is the router, and that is the switch. The issue now is that basically all of this stuff can simply be manufactured into one single thing, and so it can get a little confusing for new people because they're like, well, wait a minute. Okay, so Eli said that this is a router, but this router has switch. You can connect multiple computers to it, and it has a wireless access point. So, right, and people get confused. So the important thing to be thinking about is whenever you're looking at diagramming out a network, or you're looking for the requirements for your particular environment, think about what the logical devices that you need are, right? So you need a router. Okay, you're going to need a switch. One of the things to think about though is, do you need a 48 port switch or do you need a 3-port switch? Do you need a firewall? Do you need Wi-Fi connectivity? Do you need storage, a network attached storage device, something on the network, right? Basically, you sit down and you figure out what all the logical devices are that you need. And then you go to actually buy something that provides you all those services. And many times you will find one physical device that does the job, right? So that's a Wi-Fi access point. This has a 3-port switch. This has a NAS built into it, the whole 9 yards. So if you only need to connect a couple of computers, you may just want to purchase this physical device. On the other hand, if you need to connect like 48 ports, right? You need to buy a switch that's 48 ports. Then you might need to buy a separate switch. So that's just one of those things to keep in mind whenever we're talking about these devices. One of the things I'm going to be talking about today with routers is being VPN endpoints, so virtual private networking endpoints that, I don't know, it's questionable if that's technically what a router should do. Like when you think about a router, should a router be a VPN endpoint? And that is something I would give to the networking folks to argue about. I don't care that much. But, right, when you're sitting there trying to figure out what the actual device is, that kind of thing might be a little confusing for you. So just remember, there's a difference between the logical and the physical devices, as I've talked about many times before. The other thing to be thinking about whenever you go out to buy a router, again, whether it's an all-in-one thing or it's all separate components, is that the equipment that you're going to purchase is actually made out of hardware. This is something a lot of C-level executives can't seem to get through their minds, and one of the things that can actually confuse the ever-living hell out of noobs, right? So imagine you go into an environment and all the networking equipment works. It works. To be clear, there's not a hard fail. There's not a hard fail. You are going to learn the love of hard fails. When something fails and you know it fails, then you can figure out how to fix it. But let's say you go into an environment, especially you're new, you're a junior level admin, junior level networking person, and you have weird networking problems, and you can't really figure out what's going on. Network traffic, it seems to be a little bit slower than it should be. Connections, sessions to servers aren't connecting the way they're supposed to, right? There's a lot of just weird stupidity going on. But you go in, and the router seems to be doing routing, and the switches seems to be doing switches and all that. So that seems fine enough, and you can't really figure out where the issue is. One of the big things to remember is that within your networking equipment, there are actual CPUs, or central processing units within your networking equipment. There is RAM within your networking equipment, and there's even storage in your networking equipment. And so one of the things people kind of forget about when they're looking at networking equipment is that networking equipment improves more or less at the same rate as computers do, as smartphones do, as all of these other IoT devices do. So many times when you go into an environment and there's just weird problems. It's weird. I notice it. I actually go to a co-working space, and they have some weird problems because they have a crappy old switch, right? If you're having weird problems, one of the ways to fix those weird problems is simply to purchase modern networking equipment that will have the newest versions of processors, will have the newest versions of RAM, will have the newest versions of storage, and that you may find out that that actually solves the problems because that now there is enough hardware resources for that networking equipment to provide the services that they need to provide. Again, it's important to think about, like you go back 10 years ago, and even if you have a gigabit switch, even if you have a gigabit switch or a gigabit router, right? The reality was we were not using the internet and we were not using networking 10 years ago the way we are doing it today. Think about this. When I started doing videos, so there's a project called Everyman IT, that's when I started doing educational videos back in 2009. I actually built my own server infrastructure to distribute those videos because YouTube was literally so bad from a technical standpoint. It buffered to high hell and back, the resolution was garbage. It was actually just a really crappy service. So the reality is, you go back to 2009, 2010, you may have had a best-in-class switch or a best-in-class router, that could do a gigabit per second or whatever else, but most people weren't actually watching YouTube. Like, could it handle YouTube? Yeah, for the 3 people on your network that were watching YouTube. Again, were people doing voice over IP calls back in 2009, 2010? Were they doing Zoom calls? Were they doing all these high intensity networking tasks? And likely back then they weren't. So the networking equipment could keep up with the load of the time, but now that everybody is using Zoom and everybody has YouTube on in the background and everybody's doing all kinds of weird ass synchronization and all that kind of stuff, one of the problems you may run into with your networking equipment is that they simply do not have the processor, the RAM, the hardware resources to provide the services that you require in the modern world. So at the end of this class, we're going to go through and I'm going to show you some things. We're going to just kind of go through the features of a couple of different routers. And in that, with Cisco, you will actually see where it specifies the type of Intel CPU that the router uses, because especially at the higher levels with routers, understanding how much processing power a router has can be a very important thing. So now we need to talk about routing protocols, right? So when you have your LAN, and you're going to try to communicate with a server or another device on another LAN that is, half a world away or possibly a city away or possibly just simply in a different building, and you need to go through the internet in order to communicate with that LAN, right? As we talked about before, we have the internet cloud. Your IP traffic goes into the cloud. The cloud has millions and millions and millions of routers. Basically, your traffic goes, from all those different routers and then pops out and basically goes to the LAN that you're trying to communicate with, and then your computers are able to communicate. One of the big things to remember is whenever we talk about any concept in the technology world is nothing actually happens because of magic. Again, this may sound like, oh, hee ha ha, Eli, obviously, but it's really easy in the technology world, even for technology professionals, to start having this whole concept of magical thinking, like just because it happens, right? And the problem is once you start allowing yourself to have magical thinking, then everything starts to go to hell. It's really important to at least have a basic idea of what is going on to make the technology that you're interacting with work. And basically here, how these routers are able to know how to route your traffic through the internet is because they communicate with each other using routing protocols. So we've talked about protocols before. Protocols are languages, right? So we've talked about networking protocols before. So networking protocols are TCP/IP version 4, TCP/IP version 6, IPX, SPX, if you've heard of that, AppleTalk, if you've heard of it, NetBEUI, that you've heard of it, whatever else. Anyways, we have these networking protocols, and these are languages that are used so that computers can actually communicate with each other, create sessions, be able to send data, the whole 9 yards. You may hear of storage protocols. So storage protocols might be something like iSCSI. So this is a protocol. This is a language where you can actually use a network so that one computer essentially can be the hard drive or the storage of a different computer, right? And there's basically a protocol for that so that the computers know how to communicate with each other. What routing protocols are is they are languages for the networking world so that network devices can communicate with each other so that traffic can be routed most efficiently, right? So it's important to understand when we start talking about routing protocols, this has nothing to do with networking protocols. This isn't about TCP/IP version 4 or NetBEUI or IPX, SPX or any of this. Routing protocols is the routers or the other networking devices actually being able to communicate with each other in order to find the most efficient path for traffic to be routed based off of the current environment. When we talk about routing protocols, there's a number of different routing protocols out there. There's lots of routing protocols. We're going to talk about 3 of them today. The first routing protocol that you've probably heard of is RIP, Routing Information Protocol. And so, but what RIP does as a protocol is, let's say you have one computer over here and you have another computer over here, and then you have a whole bunch of different routers, right? So what RIP does is RIP tries to figure out the shortest path from one computer to another based off of hop count. So every time traffic goes into a router, that is considered a hop, right? So let's say we have a router for this computer here, and we have a router for this computer here. We have one connection that goes to this router, then a connection that goes to this router, then a connection up here, connection up here, connection up here. So let's say we essentially have a loop at this point. So traffic can either go all the way up. Oops, traffic can go all the way up through this router, through this router, through this router, through this router to the user, to the computer that you're trying to get to, or it can go through this one router to this router to this computer, right? So there are 2 different paths the traffic can take in order to get to the computer on the other side. With RIP, with Routing Information Protocol, it looks at the number of hops and it determines the route, the most efficient route, simply based off of that number of hops, right? So we go through one route. So we go through one router here, 2 router, 3 router, 4 router, 5 router to the computer that we're trying to go to. So this route here would have 5 hops. We look here, we go through 1 router, 2 routers, 3 routers. So this route here would have 3 hops. So therefore, using RIP, Routing Information Protocol, it would determine that 3 it's less than 5. So when you try to communicate with this computer from this computer over here, it will send the traffic on this lower route. And so that is the basics of how a RIP works. The problem that you'll notice here, though, is as I've talked about with routers, routers can be connected with different types of connections, right? They can be connected with fiber. They can be connected with Cat6. If they're going through different types of networking equipment, the speeds can be higher or lower. So like what happens here if basically these connections are like 1.5 megabits per second, but the connections up here are 1 gigabit per second, right? So there's more hops going on this higher route, right? There's 5 hops, but the 5 hops are going at 1 gigabit per second between the hops versus 1.5 megabits per second and the lower route. So the lower route will be incredibly slow at 1.5 megabits per second, where the upper route, even though it's going through 5 hops, that will be going at 1 gigabit per second. That's where we use a protocol called Open Shortest Path First, or OSPF. And what OSPF does is it looks at the actual link state. So it looks at the number of hops, and it actually looks at the link state to determine what is the currently the most efficient route to go from point A to point B, right? So you have a computer over here, you have the routers on either side, and then basically you have an upper route here. Let's say you have a middle route here, and then you have a lower route here, right? So one of the things that can be looked at is basically with Open Shortest Path First, it can see what the state of the connections are with these different routes. So it can see that this is 1.5 megabits per second here and 1.5 megabits per second here. So even though this would probably have the fewest hops in order to get from point A to point B, the speed of the hops is incredibly bad. Here, right, one of the things it may look at is you have 1 gigabit per second here and 1 gigabit per second for these 2 hops, but in the middle, maybe it only has 100 megabits per second. So basically, when the router is trying to figure out the fastest path, it'll see that these hops are at 1 gigabit per second, but it'll also know in the middle it's at 100 megabits per second. So that will be the overall the fastest speed to get from point A to point B. Again, up on this upper route, possibly all of these are actually 1 gigabit per second. So since every single hop here is at 1 gigabit per second, even though this has more hops in it, the speed of the traffic to get from one computer to the other will actually be faster. And so open shortest path first as a routing protocol understands not simply the hop number, but the actual link state for the hops. And so it will be able to determine the fastest route for your traffic. And so this can be a very important thing, especially in legacy environments where networks have been built over years, over decades. You may have many different network connections in your WAN, your wide area network, and they were basically laid down years and years and years ago, right? You may have a Cat3 connection that was laid down 30 years ago. So a Cat3 connection would only be able to give you 10 megabits per second. You may also have fiber optic lines that were run just a couple of years ago. Well, here's the thing. One of the things that you're going to learn in the real world of IT is you don't necessarily rip out equipment or infrastructure that still works. And so one of the things that you may decide is we are going to keep that 10 megabit per second connection between buildings. We're going to keep that active just in case somebody puts a backhoe through our fiber optic line, right? So just like somebody can put a backhoe through your ISP's fiber optic line, if you're on a campus facility, somebody might put a backhoe through your through your private fiber optic line. And so if you have this old 10 megabit per second a connection that's still wired up, if your fiber optic traffic line gets cut, then traffic can be routed through that 10 megabit per second line. It may be a lot slower. The network may be just sludge, but things may still be able to function properly. And so having something like open shortest path first, where you may have multiple routes, right? If somebody simply puts a backhoe through this and accidentally puts a backhoe through the other line too, then with open shortest path first, it'll be like, oh, okay, well, this right, the bottom path to get to the two computers is now the fastest that currently exists. So that's one of the routing protocols out there called open shortest path first. There is also then BGP protocol. You will most likely have heard of BGP or Border Gateway Protocol in the modern world due to the geopolitical curiosities. Again, whenever you're thinking about protocols, whenever you're thinking about technology, you have to think about what your environment is and what your situation is. So open shortest path first, that is generally used within your company's environment. So you're within your WAN, MAN, or CAN, right? If you have multiple buildings and you have them all connected with a fiber lines, that would be using open shortest path first. But what happens with all the routers that are in the cloud, right? So all the ISP routers in the cloud, all the government-owned routers in the cloud, they need to be able to communicate with each other and be able to autonomously make decisions about how traffic gets routed. And in order to do that, they use a routing protocol called BGP, Border Gateway Protocol. This is going to come as a shock to you after watching a few of my classes, but it kind of sucks. Border Gateway Protocol has been around for decades at this point, and the problem with it, much like with Ethernet and much like with TCP/IP version 4, is it wasn't really built with security in mind. So, every once in a while, a massive amount of traffic gets routed through China because somebody made a mistake. But what Border Gateway Protocol does is basically you configure your very high level routers. Again, we're talking about these routers. We're talking about internet service providers. We're talking about government institutions. We're talking about like Facebook and Google. They have routers that understand BGP. And essentially what BGP does is they advertise routes. And then when computers are trying to communicate over the internet from point A to point B based off of those routes that have been advertised, the traffic gets routed. The problem that you can have is sometimes, again, somebody in China misconfigures, as they say, misconfigures their routers, and all of a sudden traffic goes all the way through China. But that's one I'm not going to go through in this class. I'm probably never really going to go through BGP very much, but it's just something to realize when you go out there and take a look at Ars Technica, and they talk about the latest problem with Border Gateway Protocol. That's a protocol that's used by these, again, ISP level routers. And again, it's very interesting to see how little security is built into it, where a misconfiguration can just route tremendous amounts of traffic halfway around the world. So anyways, these are some of the different routing protocols that are out there. There's RIP, Routing Information Protocol, OSPF, Open Shortest Path First Protocol. Again, there's BGP, Border Gateway Protocol. These are some of the different protocols that are out there, and just something to be thinking about when you go forward with learning more about networking. And if you get into the whole Cisco or Juniper world, it's important to understand that these routing protocols exist and why they're important. Now, the next thing to talk about when we're talking about routers is NAT. We've actually talked about this in a few other classes, but today we'll go over this a little bit more specifically for routers themselves. So NAT is Network Address Translation, and essentially NAT is why we are not on TCP/IP version 6 at this point in time. So what's very important to understand is that when the internet got created as we understand it today, the concept was that every single device on the internet would have its own TCP/IP version 4 address. So the idea is every computer would be globally internet accessible, essentially. But as more and more computers, came onto the internet, networks became more sophisticated. The problem was with TCP/IP version 4 is there's only a maximum of something like 4.2 billion possible TCP/IP version 4 addresses that can ever be created. So obviously we surpassed that number of addresses years and years and years ago. And so what was created was something called Network Address Translation. What this does is it allows us to use private IP address schemes within our LANs, but then be able to communicate out with the wider internet where there's internet routable IP addresses, right? So this is where we talk about many times when I talk about 192.168.1.x, right? This is a private IP address scheme. So thousands and thousands or millions and millions and millions of LANs in the world use the 192.168.1.x address scheme because that is private, that's internal to their network. Then they go through a router to be able to access the wider internet. The external IP address of your router will then be something that's actually internet routable, 244.66.22.1, something like that, right? So every computer that's on the inside of this router will have the 192.168.1.x address scheme, but then when it goes out, essentially all the communication will be tied to this external IP address. What NAT does is it allows the router to be able to route the traffic communication that's going out and then coming back in to the appropriate computer, right? So basically you have your switch here, and you have all your computers connected to the switch. You have one computer here. This is 192.168.1.11. You have a computer over here, 192.168.1.22. Basically, this is connected to the router. The router is connected to the internet. So let's say 192.168.1.11 wants to communicate with CNN.com. So you're at your computer, and you want to pull up CNN.com. So you go from your computer, you do DNS, domain name system resolution. So you turn the domain name, CNN.com, into an IP address. Your computer knows it's not on the local network, so it goes through the default gateway, which is your router. Your router then sends this up to the internet. It ping-pongs around all over the internet till it goes out to the server for CNN.com, whatever that particular IP address is. CNN.com then responds, and it gets to the router. All right, so it gets to the external IP address of the router, which is now 208.55.66.4, something like that, right? What NAT does, network address translation, is the router knows that 192.168.1.11 was communicating with CNN.com. So when the response from CNN.com comes to the router then just sends the traffic to the appropriate IP address, is 192.168.1.11, and that is how your computers on an internal address scheme, a private address scheme, are able to communicate with the computers and servers out on the internet. It's a pretty simple concept. Generally, there's not a lot that you can do with NAT. Maybe if you get into the very, 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 very advanced, routing equipment, you can configure NAT. But for most of us, you will never have to configure NAT. But this is one of the times when the whole hardware resource question comes in, where if you're having weird problems on your network, remember NAT came out. I was taught about NAT 20 years ago. So NAT has been in routers for at least normally in routers for at least 2 decades now. But the important thing to understand is the load we were putting routers under 10 or 20 years ago is not the same as the load we're putting them under now. So if you have an old Cisco, like a 15-year-old Cisco router that has NAT on it, or maybe a Juniper router or SonicWall's been around for a long time. Anyways, if you have one of these old routers that's quote unquote doing what it's supposed to do, but your network's still a little quirky, one of the reasons may be is because the load NAT was under back in 2005, before anybody went to YouTube, before anybody was using Twitter, before we were using Zoom, right? Back then, we were literally going to CNN.com or Food Network.com. We're doing very, very basic traffic on the internet. And so one of the problems you may have now is all of your traffic is going through that 10 or 15-year-old router. That router is using NAT, network address translation, to make sure that the traffic gets back to the computers it needs to get back to. And you literally may be overloading the hardware resources of your router, and literally simply going out and buying a brand new router that may fix the problem for you. So again, that's something to be thinking about in the real world. So all network address translation does is when you go out and you communicate with something on the internet or whatever else, it just makes sure that the traffic gets back to your computer. So the next thing that we need to talk about is VPNs in regards to routing, right? So VPNs are virtual private networks. And what virtual private networks allow you to do is it allows you to connect to the internal LAN when you are remote. So if you're out in a hotel or if you're home or whatever else, and you want a print job to pop out on the printer on the internal network, right? You want to print out a document for your assistant or something like that. Essentially, you can use a VPN. A VPN will connect you into your local area network securely if you're using one of the modern VPN protocols, so that you can access the internal server. So you can connect to the Outlook email server. You can connect to the file server internally. You can literally send print jobs internally, and the whole 9 yards. One of the important things to understand, though, is that a router can be a very important key to how virtual private networks work for your environment, or if you don't want VPNs to work for your environment. Just because your employees want something to function doesn't mean you necessarily want something to function. So the first thing to talk about with this is where you can actually have your router be a VPN endpoint, right? So again, this is one of those I'm not sure if being a VPN endpoint is technically what a router is supposed to do, but it's built into a hell of a lot of routers nowadays, right? So basically, you have your router. Your router is inside your building. It's obviously connected to the switch. That is then connected to all of your servers, printers, and the whole nine yards. What you can actually have is you can have your users out in the outside world. They can connect to Wi-Fi, or they can connect to whatever local internet connection they have, and using a VPN client on their computer or their device, they can actually connect directly to the router itself. And then once they are connected to the router, then they have access to your internal environment. So this can be useful if you're not in the Windows world. Now, to be clear, if you're in the Windows world, just use something called routing a remote access server. It'll be a lot better for you. Windows actually has a VPN server service built into Active Directory servers that you can use. But let's say that you have an environment, maybe it's a Linux environment, maybe it's a Mac environment, and basically it's an environment without Microsoft Active Directory, and you're trying to figure out how to give remote users access to your internal environment. And so one of the ways that you can do it is actually having your router be a VPN endpoint. Not only that, one of the interesting things with VPN endpoints is you can actually have routers that connect to each other. So basically you can have the one router in one building connect to the router back in your headquarters, and then essentially everybody inside the building that's using the local area network, it will appear as if it's all just one big physical network to these people. So that can be useful if you have like remote sites and you want people at the remote sites to be able, again, to get to file servers, to be able to get to printers, be able to get to documents and that type of thing. You can actually use your routers to create those VPN connections. And so that's just one of those things just to keep in mind. If you do purchase a router that allows the router to be used as a VPN endpoint, just make sure you do the research and know how many concurrent connections can be active at any one time with the router. This is just one of those things that's more or less hard-coded into your router, and it will say 10 or 20 or 50 or 5,000, right? And then you just make sure that you're not going to have that many concurrent connections at one time. You can have this problem, right? If you have 100 salespeople out in the field and you figure only 50 of them will be connected to the home office at any one time, you may buy a router that only allows for 50 concurrent connections. Well, the problem is maybe it's crunch time. Maybe there's some kind of quota that the salespeople, they've got to close sales. And so all of a sudden, 60 or 70 of your salespeople are all trying to connect to the home office at the same time, but you're only allowed 50 concurrent connections, which basically means 20 people are going to be calling your help desk screaming to high hell because they need to get their quota fulfilled in order for them to get their bonuses or whatever else. So one of the things with routers nowadays is that they can be the VPN endpoints themselves. You just got to do a little bit of research to understand how your particular router allows that to happen. The other thing with routers, though, that is actually kind of interesting is the whole question of whether or not the router will allow VPN traffic through it, right? So again, with the Windows world, there's something called RAS, routing and remote access server. This is a VPN server for Microsoft Active Directory world. And so basically with this, what normally happens is your users that are in the outside world, they'll go to the external IP address of your router, 208.66.44.1. Then your router will port forward. Remember, port forward, TCP ports. It'll forward the port to whatever the IP address is of your VPN server, 192.168.1.5, let's say. And then once your user authenticates to your VPN server, they then have access to the internal LAN. Here's one of the things though. Routers actually have to be configured for what is called VPN pass-through, virtual private networking pass-through. This allows the actual VPN connections to occur. If you have a very old router, which at this point you probably shouldn't have. Even if you've got like a 15-year-old router, it should still allow for VPN pass-through. But if you have a very old VPN router, then even if you have a VPN server configured properly inside your network, and you have a VPN client configured properly outside your network, essentially the VPN traffic will not be able to go through the router because the router literally doesn't know what the hell to do with it, right? And so that's something to be thinking about if you're dealing with old networking equipment. The other interesting thing, though, is with many modern routers, VPN pass-through is an option that is generally enabled by default, but you can also stop if you want. You can also stop. So let's just say you have a school. Let's say you have a school and you have a whole bunch of kids, right? And so with your school, one of the things that you've done is you've blocked the people in your school from going to certain websites. So they cannot go to puppyporn.com. I have to be careful with the words that I use. They can't go to puppyporn.com anymore. They can't go to sexy.com. They can't go, right? Because you have kids in a school. You don't want them going to video game websites. You don't want them going to puppy porn websites. You don't want them going to any of these bad websites because you don't want to get sued for what one of your dumbass students does. But the problem you can run into is these students are students. You tell a 14-year-old, or frankly a 44-year-old, that they can't do something, and by God, they're going to figure out a way to do it, right? So when you essentially have DNS filtering, right? So when it sees puppyporn.com, it doesn't allow that to happen. If it sees sexy.com, it doesn't allow that DNS resolution to occur, that type of thing. So what a lot of students figure out is, hey, if I connect to something like TunnelBear, right? So TunnelBear, NordVPN service, right? So basically what they realize is I can use my computer, I can connect to NordVPN. Since that traffic is encrypted, the router doesn't know where I'm going to, and then from NordVPN, I can then get to puppyporn.com, and yay, I can see all the cute puppies that I want, right? Well, here's the thing. You're dealing with security on your network. Your particular situation is you have minors that are in your physical facility. You want to be able to lock down the network. So that's why you have the DNS filtering for puppyporn.com or sexy.com or whatever else. You realize that the students are getting around that DNS filtering by using VPN services because NordVPN pays millions and millions and millions of dollars to YouTubers other than Eli the Computer Guy in order to tell people they can bypass restrictions or whatever. So one of the things you can do on your router, since everything has to go through the router, is you can simply just kill VPN pass-through, right? Again, allowing VPN service through a router is something that the router actually has to be able to understand and allow. So if you simply go in and disable VPN pass-through, when the users in your network try to create a VPN tunnel out to NordVPN or TunnelBear or whatever else, the router won't allow that connection to happen, and then the kids are stuck looking at whatever websites they're supposed to be looking at. So that's just one of those things to be thinking about whenever you're dealing with routers. Again, whether the router is a VPN endpoint itself, which can be very useful, especially for connecting multiple remote offices to create like one logical environment, or again with VPN pass-through, the ability to turn off VPN services. You may also run into this problem if you're coming into a legacy environment. So again, this is a tool that can be used for security. There is a real reason why you would deny VPN access for your internal environment. One of the important things to realize is you may have had an intern or you may have had some other kind of IT professional go in and futz around with your networking equipment. And so if you're having users that they're allowed to use NordVPN or whatever else, but for some reason it's failing, one of the reasons that's failing is that VPN pass-through may have actually been turned off on the particular router that they're trying to go through. So this is just something to be thinking about from a troubleshooting standpoint. Now, one of the final things to be thinking about when you're going out there and you're looking to buy a router for your particular environment is essentially how are you going to manage your router? One of the big problems we have in the real world is you have a lot of CXOs, CEOs, managers out there, and they want their company to be real. So they'll write big checks. They will write big checks for Cisco equipment. Unfortunately, there's no institutional expertise in your company on how to deal with Cisco equipment, which can be a bit of a problem, right? If you look at the old Cisco at the command line level, especially when you're dealing with routers, I mean, you turn that thing on, you terminal into it, and it looks a whole bunch like Linux, right? You just got a blinking command prompt, and then you have to type in commands. If your people don't understand how to administer Cisco equipment, that can be a real problem. So that's one of the things that you really need to be thinking about when you're going to go provision networking equipment for your environment, and especially if you're going to replace old networking equipment that you have, right? So when you're looking at being able to manage the networking equipment, there may be command line interfaces for the networking equipment. That can be valuable because it's actually a tool for security, right? The fewer people that understand how to work on equipment, the harder it is for hackers to get in there and try to manipulate it, right? If you have a web GUI interface, anybody can understand what's going on with it, which also means one of the intern wannabe hackers in your company may also try to mess around with it, right? If it's a command line interface, that might be too complicated for the wannabe hackers. But that's something that you're going to have to be thinking about, right? There's command line interfaces for different routers, depending on who you purchase the routers from. Cisco has their own things that you have to type in, commands that you have to type in. Juniper has their own commands that you have to type in. There are GUI, there are web-based interfaces where essentially the router itself has an IP address that you can go to. You log in, that's what you're used to with normal home routers or whatever. You log in, and from there you can do configurations. There are some interesting things that I used to deal with Cisco. Some kind, I forget what it was called, but essentially that was a graphical interface. You would actually install an app onto your computer. That app would connect to your router. You could then go through and configure things graphically, and then when you hit apply, it turned all the configurations that you had put in graphically into text commands, and then sent those as text commands to your router in order to do the configurations. That's one of the ways that it can be done. The important thing for you is just to really be thinking about how are you actually going to manage your router, and most importantly, do you have the institutional expertise? Basically, do you have people in the company that are able to manage the equipment? That's when, back when I had my computer repair shop, one of the reasons I decided not to install Cisco equipment for my clients was because in order to be able to maintain the Cisco equipment, my employees would have to know the Cisco equipment. Making sure that employees stayed up to date with the knowledge required in order to maintain Cisco level equipment, I realized would just be too big a bar for what we were doing. And so we used graphical user interfaces, GUI type networking equipment. And that was one of those things that was just decided, from the business standpoint. One of the other things to be thinking about whenever you're dealing with routers, especially, and other networking equipment, is something called out-of-band management. So here's a question for you. What happens if you remotely access your networking equipment using an IP address, right? Whether it's graphical or whether it's command line or whatever else. What happens if you put a configuration into your router that essentially bricks the router? For whatever reason, it essentially cuts itself off of the internet. So you're somewhere remote, you're remotely accessing the router, you do something dumb, and you shut the router off the internet. Well, if the router is now no longer on the internet, now you can no longer remotely connect to the router and you're either going to have to do a drive or possibly a plane trip to go and actually reconfigure the router by sitting in front of it. You can stop that by having something called out-of-band management. What out-of-band management is essentially it is a network connection to your networking equipment, generally your router, that uses some other way for you to be able to connect to that router other than through your standard internet connection. So nowadays, Verizon or a lot of wireless companies, they will actually offer 4G or 5G modems with very little what's it called? Screwing up here. Very little bandwidth, essentially, right? You'll maybe get 100 megs or you'll get a gig out of it, right? It'll cost you, let's say, it'll cost you like $40 prepaid for a gig of networking. Well, you can take that little 4G modem, essentially plug it directly into your router, and then if the router fails on the internet connection, you could then actually remotely access the router and do configurations on it through that 4G or 5G connection. Back in the day, 20 years ago, we actually used to have telephone lines to every single router. So, and when I worked in the enterprise world, we had numerous remote sites with like 50 to 100 remote sites. And every single one of those remote sites, you would actually have a telephone line that would go to an external modem, one of those old US Robotics external modems. That external modem would then actually have a connection directly to the router. The idea being is that if our networking people were not able to connect to the router through the normal way, through the internet, they could literally dial in to that modem. That modem has a specific telephone number. They could dial into that modem, which would then connect them to the router itself, and they could go through and they could futz with the communications. So they had multiple ways to be able to remotely access that router in case one of the ways failed. So out-of-band management is an interesting thing. I've actually done a class on it in the past. I'll probably do another class on it for this particular series. But these are some things that you need to be thinking about. Essentially, how are you going to manage your router, and do you have the expertise within your institution to be able to manage the router that you plan to purchase? So now that we're at about the end of the class, I just want to go and take a look at some spec sheets for some different routers, just so you can get an idea of what to look at when you go out and purchase a router for yourself. So I have this page up here for Cisco routers, and one of the things I just kind of wanted to show you here is how different routers are built for different things, right? So we have this ISR 900 series. This is designed for basically branch offices, kind of like remote sites, small environments. And one of the interesting things that you're going to see here is that it's basically it's set up for only about 250 megabits per second, right? So regardless of what this is going to be connected into, it could be connected to a gigabit per second internet connection, but basically this series of routers here will only support up to 250 megabits per second. So this might be a problem that you have. You improve the internet connection to your site. You get them a gigabit per second or even more speed going to the site, but for some reason the speed to all the individual computers is still pretty slow. One of the reasons may be is that you have an old router in your environment that can only support up to 250 megabits per second. So that's one of the things to be thinking about. They have the ISR 1000 series here, right? These support up to 350 megabits per second. They do something called SD-WAN or software defined WAN. That's its own deal. I've actually done a class on that in the past. Again, I'll probably do classes on it in the future, but that's some configurations, things to think about. This one over here, ISR 4000, supports up to 3 gigabits per second. It has voice module flexibility if you're going to do that. You have SD-WAN, the whole 9 yards. If you go down to the ASR 1000, that supports up to 200 gigabits per second. It has hardware and software redundancy. So that might be an important thing in your environment. Things like redundant power supplies. If a power supply fails on your router, what happens next? Having a redundant power supply can be a very useful thing. And then you can go along and you can see different things. Like over here, you have the small business services. It allows for the VPN. It has built-in firewalls, has advanced encryption, browser-based configuration. The important thing just to understand here is that there are a lot of these different options. And again, all of this is actually within Cisco itself. If we go down here, we can take a look at one of the Cisco. Routers that I pulled up. As you'll notice here, this particular router is about $747. That is going to be an important thing when you're going and you're talking to your managers, is do remember for an enterprise or a business class environment, things are going to be more expensive than for the home environment, right? Just because you can go and you can buy a Linksys router for your home for 50 bucks, that doesn't mean that's what you should be purchasing for your company. And so that's just one of the things to keep in mind. This particular is a security router here. It has a number of different things. So it has two WAN interfaces, so you can actually connect this to two internet connections. So you could have one going to FiOS and one going to cable networking. You could do something like that. This has a switch that's built into it. So it has a 4-port switch. So that's just one of those things to be thinking about for your environment. It tells you how much RAM it has. So it has 1 gig. Maximum amount of RAM that it can have is 2 gigs. Again, we talk about the resources that are available. Just one of those things to consider. If we come down, we start looking at some of the other specifications. You can see like it talks about like the protocols that it uses. So it uses a RIP version 1 and version 2. It understands something called spanning tree protocol. It allows for L2TP tunneling, basically for VPN, for some VPN services. It has NAT built into it. That's an important thing. It has some DHCP services built into it. It has some DNS services that are built into it. And so it's important just to go through and take a look at some of this stuff just to verify that the router is going to do what it is that you need to do. You can have MAC address filtering for the switch component if you want that as a security thing. Here we talk about the VPN. So this one can actually be used as a VPN endpoint. And so it allows for 50 IPsec tunnels. So IPsec is a type of VPN. So it allows for 50, right? So if you have 10 people in the office, 50 is more than enough. If you have 100 remote workers, 50 might not be enough. Right? It just really depends on your particular environment. It also allows for IPv6 if you've got IPv6 going on. It has a firewall that's built into it. And has a whole bunch of other interesting things. Quality of service. Again, this is where I've talked before about packet prioritization, where you can prioritize voice over IP traffic to be more important than, let's say, FTP traffic. So it talks about what services it offers here. Coming down here, it talks about the management, basically how you're going to be able to manage this thing. So you have some information there. And then IPv6. So if your company is planning to go to IPv6, then this particular router does support IPv6, and it supports all these different functions within IPv6. So that kind of gives you just an idea of what this particular router does. And again, it really depends on what your environment is, what you need your router to do. If we then go down to a different router, one of the things that I think is interesting nowadays is how much is software configuration, right? So this router is a bit more expensive. Again, when we talk about prices for things, just notice that's $26,500. That is a very expensive router. Again, as I talk about, a lot of folks like to laugh at me because I buy Apple equipment. Right? A lot of the noobs out there, they're like, oh, haha, Eli buys Apple. Apple is so expensive. And as I keep trying to explain, no, a MacBook Pro in the real IT world is not expensive. I'm not even sure this is expensive, right? NetScout. There's a company called NetScout. They do like network diagnostic equipment. They sent me a sample computer in order to test and do a video on. It was $35,000. I crap you not. It was like a Windows 8 computer, but basically it has some special add-ons to it that allowed you to test your networking environment. That one computer was $35,000. So anyways, One of the things I thought was interesting here is a lot of this stuff is upgradable through software licenses. And so this is something you have to be careful about in the modern world, where we're seeing more and more where companies build hardware that can do something, but then the only way to be able to access that functionality is paying more for software licenses. So understand, when you spend $26,500, that might not be what's required to get all the functionality of your router, right? So $26,500 gets you 5 gigabits per second, which is the default. 10, 20, and 36 gigabit per second is all through software upgrade without the need for any additional hardware. So again, this is an important thing when you're speccing out your equipment. You might be like, hey, yeah, this works fine. This works fine. Look, we can get 36 gigabits per second of traffic through this router. It's going to cost us $25,000. Yeah, sure, this will be great. And then you spend the $25,000. And then you realize, oh, now you need to spend another $5,000 or something on software licensing. So do be careful about that. The other thing to be looking at here is, again, when you start getting into routers and high-level networking equipment, do make sure that you take a look at how you are going to connect the networking equipment to your network. So this has 6 SFP ports. SFP is basically a fiber optic connection, which is fine, good. No snark at all against fiber optic connections. But if you've got Cat 6 cable and you don't have a fiber optic connection, that might be a problem for you. So whenever you're buying the equipment, make sure take a look at the ports that are built in, and basically make sure you're getting the ports that you need. Again, one of the things I talked about before with like the processor, making sure you have enough hardware resources available for whatever you're trying to do. Again, this comes with a dual core 2.13 gigahertz processor that I hope for $26,000 will do everything that you need it to do. Again, redundancy. I think redundancy is interesting here. License purchase separately. So even though the redundancy may be built into this hardware, you have to purchase a license in order to get that redundancy. And then they've got the DRAM here, the RAM. They got 4 gigs. They have flash memory, essentially storage for like things like configurations. They have up to 8 gigs on here. And all of that kind of different stuff. I think that's basically all they've got here. So this is just some things to be thinking about whenever you're going to be going out and buying a router, is just take a look at what the specifications actually say and make sure you're buying what you think you're buying. So there you go. There is a class on essentially introduction to routers. So what routers allow you to do is it allows you to separate networks based off of IP address schemes. So IP address schemes are things that we can manually create. So we can manually configure a whole bunch of different IP addresses. We can create our own local area networks, and then routers are what connect our local area networks either to the WAN, the wide area network, or to the internet. Again, with routers on the internet, routers are then going to route the traffic on the internet in the most efficient way possible, essentially to get from point A to point B. Again, how that's done, they're able to communicate with each other using something called routing protocols. Protocols are simply languages in the computer world. There are a whole bunch of different types of protocols out there: networking protocols, communication protocols, storage protocols, that type of thing. In the networking world, they're called routing protocols. That's where you have protocols such as RIP, Routing Information Protocol. You have OSPF, which is Open Shortest Path First Protocol. You have BGP, Border Gateway Protocol. There's a whole bunch of different protocols out there that basically you configure so that all of your networking equipment can communicate with each other to figure out the most efficient path to be able to send traffic. Again, We've talked about NAT many times in the past at this point, network address translation. That's where you can have an internal IP address scheme and then be able to have your internal computers be able to communicate with the external world. Your internal computer goes through the router, goes to CNN.com. When CNN.com sends the response, the router knows where to direct the traffic to. That's really all network address translation is. And again, it's why we're not at IPv6 at this point, because NAT was a hell of a lot easier to implement than IPv6. With routers, they do have VPN services for the routers. Routers can be VPN endpoints, and this can be very useful for when you have remote offices and you want the offices to logically seem as if they're in the same environment as, let's say, your headquarters network. You can have one VPN router connect to a different VPN router, and then using that VPN connection, basically it's just like the equivalent of a really long patch cable, right? That's one of the things that can be done. Again, you can have remote workers connect to your VPN router so that they can access the local area network from the outside world if they're in a hotel or whatever. That's a very useful thing. Just be careful about the concurrent connections. Again, a lot of the business class routers, they'll start at something like 50 concurrent connections. That means you can have 50 remote people connected at once. 52 people try to connect, and all of a sudden you're going to be getting calls to the help desk. So that's just one of those things to consider. Again, with VPN services, with a router, there is something called VPN pass-through. This was a technology that was created years and years and years ago. Any router that you touch that's semi-modern, again, younger than 15 years will have VPN pass-through. Basically, all this is it literally allows VPN tunnels through the router, right? That was something somebody had to engineer to actually make that happen. What's interesting, though, in the modern world is you can turn off VPN pass-through. So VPN pass-through is enabled by default 99.999% of the time. But, right, if you're running into a problem where people can't create VPN connections, it might be because somebody turned off the VPN pass-through in the past as a security precaution. Or, again, if you're trying to administer your network and you have some kind of environment where you do not want people bypassing your security, simply turning off the VPN pass-through component can be a useful thing. Past that, we then get to the management. Again, managing your networking devices is just going to be one of those things that you have to decide what are you capable of, and more importantly, what is your institution capable of? Again, one of the big problems we get in the technology world is everybody gets hyper-focused on what they know. Eli, I know Cisco. Yeah, that's great. But does the person who's going to replace you know Cisco? When you get sick, do the other people on your team know Cisco, right? If you had a heart attack tomorrow and the router failed on the same day, would your team be screwed? Right? If you are the point of failure, that is not good management. So that's one of the things that you're just going to have to consider. Do you really want, command line interfaces for your networking equipment? There's some value. There is some real value there. But at the same hand, right, you may not have the institutional knowledge to be able to keep up with it. Web GUIs might be more useful. Other kind of command tools might be better for you. And so that's just one of those things that you're going to have to think about. In the same hand, out-of-band management can be very useful. If you have remote offices, there is the whole question of what happens if you put a configuration into a router that basically drops it off the internet. What's going to happen at that point? Does somebody literally have to get in an airplane in order to reconfigure the router? What out-of-band management is that you have an entirely different internet or some kind of communication connection to the router so that you can connect to the router even if it's off of the internet. There's a lot of interesting services out there. That's just one of those things that you're going to have to research. And then finally, I showed you the features and the specifications of a couple of different routers, kind of just to give you an idea of what you'll be looking at when you look at the specifications of routers. The big thing that I'll warn you nowadays is these damn software licenses. This is becoming Anyways, I'm not going to get on a rant here, but this is actually becoming a bigger and bigger problem where you buy a piece of hardware and the hardware is spec'd out to a certain degree, but you don't actually get that functionality unless you pay more money. And this can be a real big problem. Again, when you're thinking about consumer level gear, you pay $100 for a router and then you need to pay $10 for VPN services. Now, yes, that's annoying, but you can deal with it, right? You get into bigger problems though, right? You spend $26,000 on a router and then come to find out it's going to be another $5,000 or more dollars for the license that's required to get the throughput that you need. That can be a colossal disaster. So, just something to think about in the real world nowadays. Just one of those things to consider. Anyways, there you go. That was the class on routers for today. As always, I enjoy teaching this class and I look forward to seeing the next one.